Hey guys, today's lesson is going to be on adding and subtracting fractions. First of all, I wrote down a bunch of rules here that are going to help us in completing this. So the rules for today, as we have here, number one, it says we must have common denominators. So no matter what, when we're doing fractions, we need these denominators to be the same. All right, let me back up here. We need these denominators to be the same. So if we already have common denominators where they're both 3, that's fantastic. That's less work for us. However, if we don't have common denominators, if it's something like 1/4 plus 2/7 where the denominators are different, step number 1 is going to be to find a common denominator, and we need to rewrite these fractions so that they have equivalent fractions. So step number 1, must have common denominators. Once we have those common denominators, then step number 2, we're simply going to add or subtract the numerators. So if it's an adding problem, then we add the numerators. If it's a subtraction problem, we subtract the numerators. 3, our denominators are always going to stay the same. So if our denominators, when we get them to be common, if the denominator is 7, then after we add or subtract the denominator, it's still going to be 7. It's just going to come along for the ride. And then number 4, always, 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 we are going to simplify. We need to know whenever we're working with fractions, the rule is that we are going to simplify, which means reduce them. It also means if we have an improper fraction that we're going to change it to a mixed number. Okay, let's go ahead and do some. Example 1, there are 2 problems here, an A and a B. I'm going to do part A, then I'm going to let you pause it and do part B. So part A, let's go through our steps. So rule number 1 said we have to have common denominators. So I have to check. Okay, those numbers are both a 9, so that's good. They have to be the same, which in this case they are. Okay, if they're the same, then I can move on to rule number 2, which says to add or subtract the numerators. So in this case, it's an adding problem. So I add the numerators. 2 plus 5 gives me 7. Okay, move on to rule number 3, which is that the denominators will stay the same. Since they were both 9, my answer is going to be 9. So 2 9ths plus 5 9ths equals 7 9ths. I have to check, is this in simplest form? Yes, it is, because I cannot divide the 7 or the 9 by a common number. So 7 9ths is our answer. Okay, you guys go ahead and try part B on your own. So pause the video, give it a try. Okay, we're back. Again, so let's compare your answer to what we did. We have to check and say, are the denominators the same? Okay, that's always step 1. In this case, they are the same. They're both 12s. So that's going to come along for the ride. Okay, then I can go ahead and add the numerators. So I do 5 plus 3, which gives me 8 twelfths. And then always, always, always we have to try to simplify. So I know that 8 and 12 can both be divisible by 4. So I'm going to go ahead and reduce this. 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3 is our final answer. Now, I'm going to point this out. Some of you might have got to the 8 twelfths, and instead of divided by 4, you divided by 2. That would be okay as well, because you'd get 4/6. But then you always have to check that that's not a final answer, because you can reduce it by 2 again, and that's going to give us then the 2/3 that we have down here. Okay? All right, example 2. So example 1, we did 2 adding problems. Example 2, we're going to be doing 2 subtracting problems. Again, I'll do part A, you can do part B. So part A, we say, are the denominators the same? Yes, they're both 8. Okay, so the 8's going to come along for the ride. It stays the same. Since this is a subtraction problem, I'm going to go ahead and subtract the numerators. 7 minus 3 gives me 4. So I get 4/8. Last step always is we always, always, always simplify. Again, I can see that 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Final answer is 1/2. Okay, part B, 13/14 minus 3/14. Try that one on your own, guys. Okay, you're back. Check the denominators. They're both 14. That means they're the same. So the 14 comes along for the ride. 13/14 minus 3/14. So we subtract the numerators. 13 minus 3 gives me 10/14. Then, of course, I know that those are both even numbers, so I can divide them by 2. So we got to try to simplify. 10 divided by 2 is 5. 14 divided by 2 is 7. I get 5/7. That is in simplest form. 5/7 is my answer. Okay, so we did example 1 was adding. Example 2 is subtracting. Now we move on to example 3 here. Again, A and a B, I'll do A, I'll let you do B. But what you notice on this page is what happens if we don't have common denominators? Meaning in this problem, my denominator is a 4 and a 3. They're not the same. Okay, so what we have to do is change these over. Okay, and this is what we practiced when we did finding least common multiple, when we did equivalent fractions. We have to rewrite these two fractions as equivalent fractions. So what I'm going to do is this. Get rid of my arrows. Now I'm going to say I need both of these fractions to change. Okay, the 4 and the 3, I need a common denominator. I know they both can become 12. Okay, so I'm going to change that. So what I can do here, since this denominator is a 4, it has to become a 12. I know that has to be times 3. So then I do the 3 times 3, which gives me 9 twelfths. On to the 2/3. Well, the 3 has to be multiplied by 4 to get 12. So then I have to do 2 times 4, which gives me 8. So the problem ends up becoming 9 twelfths plus 8 twelfths. Now I have common denominators. Now I can go ahead and do the problem. So the denominators are the same. They can come along for the ride. Then I add the numerators. 9 plus 8 is 17. Okay, I can't reduce this. There isn't anything that I can divide both 17 and 12 by. But what I notice is that this is an improper fraction. Remember what improper means. It's something that shouldn't be. It's not right, or shouldn't have that. It's not proper. Well, I have to make this proper. Okay, so what we say is this. How many times does 12 go into 17? Well, it goes into there one whole time. That gives me 12. And then to get to 17, I need an extra 5 to get to 17. And the denominator still stays the same. So when it's an improper fraction, we need to change it into a mixed number to be in correct form, something that's acceptable as our answer. So always reduce and always make improper fractions mixed numbers. Okay, part B, go ahead and do that one on your own. Pause the video. All right, we're back. Last problem. Let's see if we got it. I see the 8 and the 16 they are not the same. So we're going to change these to common denominators, which 8 and 16 can both become 16. Well, the 7/16 doesn't have to change. I can just rewrite that. But the 8 has to be multiplied by 2 to become 16, which means I do 5 times 2, which gives me 10/16. Okay, denominators are both 16, so that stays the same. Numerators, 10 minus 7 is 3. 3/16 is in simplest form. That's our final answer, and we are done. So that's the lesson. If you have questions, make sure you ask.